Continuing our exploration on solving trig equations, today we're going to solve ones that are not just simply something like this. Cosine of x equals the square root of 3 over 2. Now that one's pretty basic. We can find where the cosines equal the root 3 over 2 and we're done. We're going to solve more elaborate ones that I like to call the double or triple angle equations. So we're going to solve equations like this. 2 sine of 2x plus 1 equals 0. We're going to follow a lot of the same approaches, but then we're going to have to expand our knowledge a little bit, because now it's not just the sine of x, it's the sine of 2x. Now what that does is that it basically takes our trig equation and it shortens the period of it, which means that it's going to take less time for the values to repeat. Now because we're solving from 0 to 2 pi, if we took that 2x, that really only gives us answers between 0 and pi. So we're going to have to expand it a little bit and do a little bit of work to get all of our answers in that interval. But before we do anything, we want to get that sine of 2x by itself. So we're going to go through the process we did before. I'm going to do this kind of in a 2 for 1. I'm going to take away 1 and then divide by 2 to give me negative 1/2. So here's what I'm going to do. I'm going to pretend that it's just the sine of x equals negative 1/2. I know I'm in quadrant 3, and I know I'm in quadrant 4. Now, where is the sine equal to negative 1/2? It's equal to the pi over 6's. So I'm going to first start off by writing my two answers out. 7 pi over 6 and 11 pi over 6. Those are the two places that if it was just sine of x equals negative 1/2, those would be my solutions. But that actually corresponds to some angles in here, and you're like, wait a minute, that's right. Trust me on this. We're going to have to do something else with this. We're going to actually go around the unit circle one more time. So I know it's going to still occur in the same places, the 7 pi over 6 and 11 pi over 6, but now with 2 pi added to it, because every rotation around the circle adds 2 pi. So I want to think about, what is 2 pi equal to when I'm talking about something over 6? Well, it's 12 pi over 6. 12 over 6 gives me 2. So if those solutions occur in the same spot, but one more rotation around, I'm going to actually add 12 pi over 6 to each of my answers. So I've got 7 pi over 6 plus 12 will give me 19 pi over 6. And 11 pi over 6, adding 12 to that, gives me 23 pi over 6. But we've got a major problem, because those are actually not our answers yet. And not only that, but they're outside of our window from 0 to 2 pi, especially these two right here. So like I said before, what ends up happening is with that 2, our answers are going to occur twice as quickly as we expect. So instead of happening here at 7 pi over 6, it's actually going to happen somewhere more like right in here. Halfway, or half of the way from 0 to 7 pi over 6. So to think about that, what that really means is that because it's half as quick, or twice as quick, I guess, my denominator is actually going to end up doubling. And I'm going to do that for all 4 of them. So those are my 4 solutions. Now what I expected was to have 2 answers, because that's typically what we've seen with our trig equations. However, because of that 2x, that actually doubled the number of solutions, because it cut in half the time it took to get those solutions. Whoa, amazing stuff. All right, let's try another one. Let's do another one that's a 2x. Let's try tangent of 2x minus root 3 equals 0. Now, very similar to this one, we're going to start by bringing some stuff over. Tangent of 2x equals the square root of 3. I've got tangent by itself, so now I'm trying to figure out where is it equal to the square root of 3. First of all, which quadrants am I in? I'm in quadrant 1, and I'm in quadrant 3. Tangent is equal to root 3 at pi over 3 and at 4 pi over 3. But I've got that 2x, which means I've got to go around another 2 pi. So I'm going to change this now. Instead of 2 pi equals 12 pi over 6, I want it to be something over 3, because that's my denominator here. So I'm trying to think about what divided by 3 gives me 2, 6. So I'm going to add 6 pi over 3 to both of these things. So this is really a 1. I'm going to make that then 1 plus 6 is 7 pi over 3. And the second one, taking 4 pi over 3 plus another 6, gives me 10 pi over 3. Again, I'm looking for 2 rotations because of that 2. If there were more, I'd go around more. We'll get to that next. But again, these are not my answers. To find my answers, I'm going to take those denominators and double them. Pi over 6, 4 pi over 6, 7 pi over 6, and 10 pi over 6 are my 4 answers. Notice, though, my fractions, I did not reduce them. Now, your call if you want to, but I'm not going to reduce those fractions because really the main idea is that we know how many solutions we have and generally where they are. Now, if I did reduce that, 4 pi over 6 would become 2 pi over 3. 10 pi over 6 would be 5 pi over 3. So that's what happens when we have a 2x. What happens when it's a 3x? Let's find out. So let's take one of our equations here. Let's take square root of 2 cosine of 3x plus 1 equals 0. So I'm going to solve it. Cosine 3x equals negative 1 over the square root of 2, which no good. I want to rationalize that. Now, if it was just cosine of x, pretty basic equation. We know it's in quadrant 2 and 3. It's the pi over 4s. 3 pi over 4, 5 pi over 4. And again, I'm going to add 2 pi. My denominator is 4. So I'm basically adding 8 pi over 4 to each of those solutions. But I actually need to go around now 3 times. So the first time around, I've got my 3 pi over 4 and 5 pi over 4. If I add another rotation around, I'll be at 11 pi over 4 and 13 pi over 4. But if I go one more time, because it's a 3x, not a 2x, a 3x, I'm going around. This is first rotation, second rotation. Now my third rotation is 8 more than these. So 19 pi over 4. And 13, oh, not 13. It was 13. 21 pi over 4. Now, because I went around 3 times, my solutions occurred 3 times as fast as I expected. I'm going to take my denominator and multiply by 3, giving me 3 pi over 12, 5 pi over 12, 11 pi over 12, 13 pi over 12, 19 pi over 12, and 21 pi over 12. I expected to have 2 solutions, and I ended up with 6 solutions. Because again, that 3x means I have 3 times as many solutions as I normally would have, because that graph has been shrunken down and occurs 3 times as fast as it normally would. So that's how we're going to solve equations where we're looking at a double or a triple angle. So again, pretend it's a normal equation and then go around as many times as you need and then multiply the denominator by that new number. If it's a 2, multiply the denominator by 2. If it's a 3, multiply the denominator by 3.